In 2015, attackers shut down power to 230,000 people in Ukraine. They did not break any encryption. They did not bypass any authentication system. They walked through the front door because there was no DMZ. In this video, we are going to cover exactly what a DMZ does, how it stops the most common attack paths into an ICS network, and where it still fails. Let us start with a flat network, no segmentation at all. On the left, your OT zone, the DCS, the PLCs, the field devices. On the right, the corporate IT network. In a flat network, these two talk directly. Your historian has an IP on the same subnet as your engineering workstation, which shares a switch with the corporate email server. One compromised laptop on the IT side, one Modbus write command, and your control valve opens to 100%. The PLC did not ask why. It just obeyed. A DMZ changes the architecture completely. Now you have three zones. The OT zone on the left, your DCS, PLCs, SAS. The IT zone on the right, corporate systems, internet access. And between them, a third zone, the DMZ, a demilitarized zone. The DMZ is a buffer. Nothing in IT can reach anything in OT directly. Data only moves through the DMZ, never through it from end to end. Two firewalls enforce this. One between IT and the DMZ. One between the DMZ and OT. You need both. One firewall is not a DMZ. The two-firewall rule is not optional. Here's why. If you have only one firewall between IT and OT, an attacker who compromises that firewall has a direct path to your DCS. But if you have two, breaching the outer firewall puts the attacker in the DMZ only, still separated from OT by a second firewall with its own rule set. Defense in depth means each boundary has its own policy. The inner firewall protecting OT can be significantly more restrictive than the outer one facing IT. What lives in the DMZ? In almost every refinery and power plant, the answer starts with the historian. Your OPC historian, whether it is PI Server, Wonderware, or Exaquantum, lives in the DMZ. The DCS pushes process data up to the historian using OPC or IEC 61850. The corporate BI systems read from the historian over HTTPS. Notice what does not happen. IT never needs a connection that goes through the historian and into the DCS. IT reads from the historian. The historian is a one-way mirror. OT writes. IT reads. There is no path through. The DMZ is not a physical thing. It is a set of rules. These four rules define it. Rule 1. Allow OT to push data to the DMZ. Port 102, port 4840, OPCUA, whatever your historian needs. Rule 2. Allow IT to read from the DMZ. HTTPS on port 443, read-only. Rule 3. Deny IT to OT. Any protocol, any port, no exception. Rule 4. Deny DMZ to OT, except a single, specific jump server IP with multi-factor authentication and session recording. If Rule 3 is missing, you do not have a DMZ. You have a slightly more complicated flat network. When a misconfigured firewall rule is an unacceptable risk in nuclear facilities, chemical plants, high-criticality petrochemical, engineers use a data diode. A data diode is not software. It is a hardware device with a single fiber transmit path and no receive path. Data flows in one direction. It is physically impossible to send a command in the reverse direction. There is no wire for it. Vendors like Waterfall Security and Owl Cyber Defense build these. The trade-off: no acknowledgement, no polling, no bidirectional protocols. You get absolute one-way enforcement with zero software attack surface. Here is the problem the DMZ does not solve on its own. Maintenance engineers need to reach the OT network remotely. Vendors need to access the DCS for commissioning and updates. That access goes through a jump server, a bastion host in the DMZ. When it is configured correctly, multi-factor authentication, time-limited sessions, every keystroke logged. But if an attacker compromises the jump server, they now have a foothold inside the DMZ, one step from OT. This is how most real DMZ bypasses happen in practice. The jump server is your highest value target in the DMZ. Treat it accordingly. So what does a DMZ actually change? Without one, the attack path is IT network, one hop, OT network. With a DMZ, that path is broken at 2 points. The attacker must breach 2 firewalls or compromise a server in the DMZ before reaching any OT asset. The DMZ does not stop every attack. It breaks the direct path. It forces the attacker to take more steps, spend more time, make more noise. And in OT security, more time means more opportunity to detect and respond before physical impact. The DMZ is not a silver bullet. It is a structural requirement for any ICS network connected to an enterprise environment.